Hi guys, today's video I'm just going to go through a few examples on factorising. I'm going to show you two types in this video. So factorising by taking out common factors and also factorising difference of perfect squares. The first thing you should always look for when you're factorising is common factors. Just before we get into some examples though, remember when we expand an expression, so here's an expression that has brackets, 3 times by x plus 5, we multiply the term in front of the bracket by each term inside the bracket. So we're going to start here by doing 3 times x, which is 3x, and then 3 times 5, which is 15. In this case, it's a positive 5, so it's positive 15. This is what we call expanding. You're removing those brackets. Factorising is the opposite. It's going from an expression that doesn't have brackets back into an expression that does have brackets. So that's what factorising is, if you can remember back to the quadratic equations topic. So I'm going to show you 3 examples here of factorising by taking out a common factor. And like I said, the first thing you should look for when you factorise is, are there any common factors between my terms? So this first expression here, there are 2 terms, minus 3x and minus 12. So I'm going to find the highest common factor between those 2 terms. In this case, that highest common factor is minus 3. So what we're going to do is put that minus 3 at the front, set up some brackets, and inside the brackets is going to be the other part of the term that we multiply by minus 3 to get that original term. So in this case, minus 3 times by what would give me minus 3x? Well, it's minus 3 times by x. Okay, now minus 3 times by what would give me minus 12. Minus 3 times by positive 4 would give me minus 12, so let's put a plus 4 inside those brackets. If you can, always try and get that minus sign on the outside, especially if it's, common between the 2 terms we have in our original expression. Alright, let's look at the second expression. Again, 2 terms, 20a squared plus 30a. So common factor between these 2 terms is 10, but also the a. A is common to both terms. So we're going to put out the front 10a, set up our brackets. Now 10a times by what will give me 20a squared. 10a times by 2a is 20a squared. 10a times by what will give me positive 30a. This time it's just plus 3. 10a times by positive 3 is positive 30a. One way of checking to make sure if you've got it right is to actually re-expand these brackets, and it should equal that original expression you start with. Okay, this one's a little bit trickier. We have, again, just 2 terms, 6xyz squared and minus 3z squared. Here, the common term is going to be 3z squared. So that goes out the front. Set up my brackets. Inside is what's left over. So 3x squared multiplied by what will give me 6xyz squared. Well, 3 times by 2 gives me 6. And then to get the x and y, I'm just going to add those in here. Okay. 3z squared times by what equals minus 3zy squared. Well, it's just minus 1. Okay, and again you can check by multiplying the term in front of the bracket by each term inside the bracket to expand to see if you get that original expression. Okay, the second set of examples we're going to look at is factorising the difference of perfect squares, or sometimes referred to as DOPS, difference of perfect squares. Okay, you see in these examples we have, again, 2 terms per expression. Notice in this first one, both of those terms are actually square terms. Okay, 16 is a square number, x squared is a square term, it's x times x, and they're separated by a subtraction sign. So it's the difference of these 2 perfect squares. So to factorise this, what you need to do is set up 2 sets of brackets, okay, and then basically at the front of the brackets goes the square root of the first term, so the square root of x squared is just x, and then at the back of the brackets goes the square root of the second term, which in this case, 4 times 4 gives me 16. So the square root of 16 is 4. And then inside each bracket, separate those two terms by a plus and a subtraction sign. Okay, pretty straightforward. Again, it's the same process with this second example I've got. Set up your two sets of brackets. Again, there's two squared terms separated by a subtraction sign. So 3a squared, square root of that is simply 3a. So that goes at the front of both brackets. 4b squared, the square root of that is simply 2b. And again, we just separate those terms by a plus and a minus. It doesn't actually matter if the minus is here and the plus is here, as long as you have one bracket that has an addition and one bracket that has a subtraction sign in it. Okay, this final example I'm going to look at today in this video is actually a combination of taking out common factors and then difference of perfect squares. Because you look at this, 12 isn't actually a square number, and neither is 1,452. But looking at these two terms in this expression, there is a common factor. 12 is in fact a common factor, believe it or not, to 1,452. And if I was to simplify, to factorize this by taking out that common factor, which is 12, it goes at the front, then I'm left with 12 times by what gives me 12y squared. Well, it's 12 times y squared. And then 12 times by what gives me 1,452. Well, it's 12 times by, believe it or not, 121. Now you notice that I do have inside the brackets two square terms. Y squared term is y times y, and 121 is a square number, 11 times 11. So what we can do now, 12 stays at the front, set up your two sets of brackets. At the front goes the square root of the first term, which is y. At the back goes the square root of the second term, which is 11. And then we separate those with addition and subtraction. Again, it doesn't matter what order they're in. Okay, so hopefully this helps. Next video I'm going to show is basically looking at perfect squares and some product type of factorizing, which is going to help with us sketching those parabolas.